In this second part of the Nissan Moco engine disassembly and overhaul, we are diving deep into the removal and inspection of the most critical and sensitive components of the engine. As you know from part 1 of this series, we previously disconnected the external components and dropped the engine from the vehicle frame. Today, our entire focus shifts to the top side of the engine, specifically targeting the fuel delivery system and the air intake manifold. When working on any Japanese EFI engine, precision and caution are your absolute best friends. The wiring harnesses, electronic sensor couplers, and vacuum lines on these vehicles become brittle over time, and a single mistake or forced movement can cause expensive structural or electrical damage. Our first major step in this procedure is the removal of the fuel injector assembly. Since this is a lightweight 3-cylinder engine, it features 3 individual fuel injectors mounted directly underneath a shared fuel rail. To begin the extraction, we carefully disconnected the main electrical wiring harness and popped the safety clips securing the couplers to each injector. This requires a gentle touch because forcing plastic clips that have been exposed to years of engine heat will cause them to snap instantly. Once the wiring harness was safely tucked aside, we used a proper socket wrench and T-spanner to unbolt the fuel rail from the intake assembly. While pulling the fuel rail upward, extreme care must be taken to ensure that the rubber O-rings and lower injector cushions do not get torn or left behind in the ports. Hardened or damaged injector seals are a major hazard. If they fail to seal properly upon reassembly, they will cause high-pressure fuel leaks that can easily spark an engine bay fire. Upon inspecting the extracted injectors, we noticed visible carbon buildup and slight rust around the nozzle tips. These will later be placed into an ultrasonic cleaning machine to restore their perfect fuel spray pattern. With the fuel rail and injectors successfully set aside, we moved on to our next big target, removing the intake manifold. The intake manifold is responsible for routing clean air into the engine cylinders. However, because modern EFI engines utilize exhaust gas recirculation, EGR systems, and positive crankcase ventilation, heavy carbon vapors and oily blow-by gases travel through this chamber, accumulating over time. The mounting bolts for this manifold are located in tight, recessed spaces where standard open-ended wrenches cannot reach. To tackle this, we utilized flexible joints, extension rods, and deep sockets to ensure we had a perfect grip on every bolt head without slipping or rounding them off. We loosened the nuts and bolts in a cross-pattern sequence to relieve tension evenly across the manifold body. The moment the intake manifold was separated from the engine head, the root cause of the vehicle's poor fuel economy and sluggish acceleration became immediately obvious. A thick, stubborn layer of black carbon crust had choked the interior walls of the manifold and heavily restricted the cylinder head intake ports. When these passages are restricted by carbon, the engine's volumetric efficiency drops drastically. The restricted airflow causes the engine to struggle during acceleration, leading to rough idling, loss of power under load, and severe engine knocking. For now, we are leaving this carbon undisturbed as we complete the rest of the teardown. Once the entire engine block and cylinder head are completely stripped down, the intake manifold will undergo a thorough chemical wash and diesel degreasing to restore its internal airflow to factory new conditions. After successfully removing the fuel injectors and the intake manifold in the previous segment, we are now diving straight into the next highly critical, technical, and time-consuming phase of this Nissan Moco 3-cylinder engine disassembly. Because this specific video clip is exactly 5 minutes and 18 seconds long, we have the perfect opportunity to slow down our explanation and document every single mechanical detail, proper tool application, and internal component inspection step by step. In this extended segment, our primary objective is to remove the tappet cover, commonly known as the valve cover, and then completely clear out the entire exhaust and accessory side of the engine block by removing the exhaust manifold, the AC compressor, and its heavy mounting brackets. This phase of the overhaul requires absolute patience, precision, and an experienced touch because dealing with old, heat-exposed components can easily lead to broken parts or stripped threads if you rush through the process. Let us begin with the tappet cover removal, which takes up a large portion of the opening minutes in this video clip. There are multiple 10mm bolts securing this lightweight aluminum cover to the top of the cylinder head. When dealing with compact, high-efficiency Japanese engines, like this K6A powertrain, you must never loosen these structural bolts randomly or with an impact gun. We utilized a high-quality 10mm deep socket, an extension bar, and a smooth fine-tooth ratchet to loosen each bolt just a quarter turn at a time, in a precise cross-pattern sequence, starting from the outside edges and working our way inward. This careful method ensures that the aluminum cover does not warp, bend, twist, or crack due to uneven residual tension stored in the metal. Once all the bolts were completely unthreaded and safely placed into our magnetic tray, we gently tapped the sides of the cover with a soft plastic mallet to break the old silicone gasket seal without scratching the mating surfaces. The moment the tappet cover was lifted off, the entire internal valve train, the twin camshafts, the bearing caps, and the timing chain sprocket assembly were fully revealed. Looking closely at the internal components, there is a very visible, thick layer of black oil sludge and heavy carbon crust coating the walls and valleys. This heavy sludge is a textbook sign of neglected vehicle maintenance. Either the previous owner severely delayed their routine oil changes, or they were using cheap, low-grade engine oil that completely broke down under intense internal engine temperatures. While the camshaft lobes themselves do not show deep scoring, pitting, or catastrophic wear, the heavy varnishing across the valve lifters means we will need to perform a deep chemical flush and manual cleaning later on. Mark in the video, we shift our focus entirely to the front and side profile of the engine block to tackle the exhaust manifold assembly. Disassembling an exhaust manifold is notoriously one of the most stubborn and high-risk tasks in professional automotive repair. Because the exhaust system experiences thousands of extreme heat cycles, the metal constantly expands and contracts, causing the mounting studs and nuts to heavily oxidize, rust, and seize tightly together. If a mechanic applies brute force here with a standard pneumatic gun, or an incorrect socket size, there is an extremely high chance of snapping a hardened steel stud clean off inside the aluminum cylinder head. To prevent this major headache, which usually requires drilling out the broken stud, or taking the entire head to a lathe machine shop for spark erosion, we took our time. We sprayed every single nut with a professional-grade rust-penetrant spray and let it soak for a few minutes to lubricate the threads, using a heavy-duty 6-point socket to maximize surface area contact and prevent rounding the corners of the rusted nuts. We carefully cracked each nut loose using steady manual pressure. At the beginning of this clip, our main focus is directed toward the lower section, on the left side of the front bumper. Positioned directly behind the bumper skin is a specific black plastic strip, which is professionally recognized as the lower splash guard extension, or undercar shield support bar. The engineering purpose of this specific structural strip is twofold. It provides structural stability to the lower aerodynamic edge of the bumper, while simultaneously acting as a protective barrier to block mud, debris, and water kicked up by the front wheel well from penetrating the engine bay and degrading the sensitive drive belts, tensioners, and accessory pulleys. We took extra care when unthreading the combinations of 10mm screws and plastic retaining clips holding this strip in place, as components located in this high-moisture splash zone become extremely brittle over time due to constant road grime accumulation. After successfully unbolting and unclipping this plastic shield, we have managed to open up a wide, highly accessible workspace between the inner structural sidewall and the engine's main pulley system, allowing us to proceed smoothly with the upcoming steps. Moving forward in the teardown, our next major objective was to loosen and remove the left side engine timing mount assembly. During a complete engine overhaul, the structural mountings play a critical role, as they bear the permanent physical load of the powertrain, while dampening harmonic vibrations before they can transfer into the vehicle's chassis and passenger cabin. Before cracking a single bolt on this left side mount, we properly supported the engine block from underneath, using a heavy-duty hydraulic floor jack paired with a thick wooden block to safely distribute the pressure across the oil pan. This crucial step ensures the entire engine structure does not drop or shift downward when the structural bolts are pulled, which would otherwise cross-thread the fasteners. Once the weight of the engine block was safely and completely transferred onto the hydraulic jack, we utilized a professional breaker bar, along with high-tensile 14mm and 17mm deep sockets, to break the initial factory torque on the main mounting bracket fasteners. These specific chassis bolts are tightened under high torque specifications, requiring steady, directional manual leverage to ensure the internal threads remain fully intact. One by one, all structural bolts were smoothly unthreaded, allowing us to pull the left timing mount frame and its internal rubber vibration dampener completely out of the engine bay. Upon close visual inspection of the rubber bushing insert, we noted hairline fatigue cracks. which explain the increased cabin vibrations experienced over time. The moment the engine mount pathway was entirely clear, we advanced immediately to unbolting the air conditioning compressor and its heavy-duty casting bracket assembly. The AC compressor is tightly packaged directly against the lower flank of the engine block, which requires the use of specialized swiveling universal joints and extra-long extension rods to gain clean mechanical access. Our first action was to depress the safety locking tab on the electrical wiring harness connector to pull it apart safely without damaging the old terminal connection. Next, we unthreaded the long, high-tensile mounting bolts that clamp the compressor body directly to its base. After freeing the compressor from its mounting points, we exercised extreme caution to suspend the assembly safely out of the way without putting any uneven structural stress or tension on the aluminum AC lines, thereby preserving the system seals and preventing any accidental loss or leakage of the pressurized refrigerant gas. Finally, we turned our attention to the heavy cast-iron compressor mounting bracket bolted directly into the side profile of the bare engine block. We have now entered a highly critical and specific phase of this Nissan Moco 3-cylinder engine disassembly. In this new video clip, our entire focus is on removing those parts that are directly connected to the main joints of the engine block and cylinder head, without opening which we can never separate the timing chain cover. At the beginning of this clip, the first and major task you see on the screen is the complete removal of this engine's exhaust manifold. As you know, the exhaust manifold is that part of the vehicle which routes the extremely hot gases exiting the cylinders toward the silencer, due to which the temperature in this zone reaches thousands of degrees. Because of this continuous heating and cooling cycle, its studs and nuts become badly seized, rusted, and brittle. Any kind of haste or the use of an incorrect impact gun here can snap the studs clean off inside. To avoid this danger, we had already applied a generous amount of high-quality penetrant oil and rust remover spray beforehand, so that the rust could soften up deep inside. After that, using a specific 6-point deep socket and breaker bar, while applying perfectly straight and even pressure, we cracked all the nuts one by one. Maintaining hand balance while loosening these nuts is extremely vital, so that the tool does not slip and round off the corners of the nuts. After separating the exhaust manifold from the head, when we inspected its internal ports, we noticed a slight wet shine along with the carbon, which clearly testifies to the fact that the valve seals inside the engine have weakened, causing oil to leak and burn inside the combustion chamber, the actual reason behind the vehicle blowing smoke and consuming oil. After safely placing the exhaust manifold to the side, our next major target was to remove the main engine mounting on the timing side. In any vehicle, the job of an engine mount is not just to hold the engine up, but when the vehicle moves, gears change, or acceleration happens, it absorbs the shocks and vibrations produced by the engine to keep the chassis frame protected. Since this left side timing mount bears the primary weight of the engine, we took full safety precautions before loosening it. We placed a proper hydraulic floor jack underneath the engine and kept a thick wooden block in between to protect the oil pan from damage so that the weight could be distributed evenly. With the help of the jack, we slightly lifted the engine to completely relieve the structural load and tension from the mounting bolts. If you unbolt them without removing the load, the bolt threads will get badly stripped, ruining the internal threads inside the block. Once the weight was safely shifted, we utilized 14mm and 17mm heavy-duty sockets to loosen those structural mounting bracket bolts that are tightened down to very high torque specifications. One by one, the entire mounting assembly frame and its internal rubber pad were pulled out. Looking closely at this rubber bushing, deep cracks and wear marks are clearly visible, which was causing the cabin vibrations and strange noises inside the vehicle. With the entire mounting setup removed, the path to the timing chain cover is now mostly clear. But there is another major obstacle here that must be removed, and that is the vehicle's water body pulley. The water body pulley is a crucial component of the vehicle's cooling system, which spins the water pump via the drive belt to circulate coolant throughout the engine block and cylinder head. At the end of this video clip, you can see us working on loosening the bolts of this water body pulley. Loosening these pulley bolts can be quite tricky for young apprentices, because the moment you apply a wrench or ratchet to a bolt, the entire pulley starts spinning along with it. To lock it in place, we wrapped an old drive belt around the pulley to create a firm grip, or utilized a screwdriver between two bolts to create leverage and hold the pulley, removing the main oil chamber. also known as the oil pan or sump. The moment the chamber was pulled off the bottom of the engine block, the very first thing we noticed was that it was incredibly dirty, heavily coated with a thick layer of black sludge and metallic debris accumulation at the bottom. Even more concerning and alarming was the visible presence of water and coolant mixed directly into the engine oil inside the pan, turning the fluid into a milky, contaminated mixture. When water mixes with engine oil, it completely breaks down the oil's viscosity, leading to a catastrophic failure of the entire lubrication system and causing severe friction wear across the main bearings, crank journals, and piston skirts. After setting the contaminated pan aside, we removed the front timing cover plate, which was also heavily caked in old, burnt oil, silicone residue, and road grime, which will require a deep chemical degreasing and pressure washing before reassembly. Further in the clip, we showcase the core layout of the bare engine block and the completely separated cylinder head assembly. To accurately test the structural health of the valves and check for micro leaks across the combustion chambers, we conducted a standard manual petrol leak test. We flipped the cylinder head completely upside down on our workbench, ensuring it was level, and poured highly fluid petrol directly into the dome of the combustion chambers, completely submerging the closed valve faces. If the valve seats and faces are sealing perfectly with factory precision, the petrol should hold its level completely without seeping through into the intake or exhaust ports. However, as you can clearly see in the video, the petrol immediately started leaking and draining past the valve edges, pouring out through the manifold ports almost instantly. This definitive failure confirms that the valve faces and seats are badly worn out, pitted, and distorted, causing a major loss of engine compression, which explains the severe engine misfiring, poor idling, and lack of power. These valves will now need to go to the machine shop to be replaced, cut on a lathe machine, and undergo a precise hand-lapping process to restore a perfect airtight seal.